Right, there's me valves in. Very fiddly to get those into that little hole. All those little tiny collets in there. Hard to get them in. Down there and down there. So basically it went from 1, 2, 3, 4. So exhaust valve on number 1 and exhaust valve on number 2. And I've had to weld that and that and that to make it the same height. Otherwise them ones would rattle. It might have worked, but it'd rattle. You might have got a bit of back pressure on the engine as well. But now, thankfully, thanks to MIG welders and stainless steel, I've been able to put some stainless on the end of that and get them up to right level. Just don't kill the groove, like she's singing about. Don't kill the groove, because otherwise your collets will not fit in when you're putting them back on. And if you don't know what the groove is, I've got the broken valve in here somewhere kicking around. Let's have a look, here it is. If you don't know what the groove is, what she's singing about, in my mind, that's the groove there. See the groove? That's what they click into. It's like two little shells. They clink onto the outside of that. And if that tip is not the correct height, then these little hydraulic tappets will be lower down. See, because they sit on top of them and they move up and down with rocker. As the lobe on the rocker goes around and around like an egg, pushes it up and down. But if that doesn't adjust correctly, because these ones look different to K16. K16, the inner parts look substantially different to that. And they move in and out. The shiny bit in the middle moves in and out and gets fatter and thinner, like taller and shorter. It takes up the slack on the it's a hydraulic tappet. Builds pressure up, and as the cam comes around, it pushes on that. So I have to put that one in. So whatever it is, which one is that one? That's exhaust valve number 1. So that's number 1 exhaust valve. Yeah. What you do is you get a load of oil. You put loads of oil all over it. Make sure that there's loads of oil all over that. It's hard to do it with one finger, but put loads of oil around that so that it's lovely and glued up. And then you get loads of oil. And you put loads of oil down inside that area as well. But you want to make sure that your nice new valves go up and down smoothly. So when it's going up and down with cam going around and around, when it pushes that down, it slides up and down. Plenty of oil around that. That's what got stuck. When the water run out, not necessarily need it on top like that. That's just enough for what I'm after to demonstrate that. But you don't necessarily need lots of oil after it lubes itself up as it's going around and around. But what caused it to seize up was the water pump. Temperature got too high. One of the valves obviously got a bit too hard, and the cam weren't able to turn it. And I'm guessing the sprocket on the end, because it doesn't have a roll pin in it, weren't able to rotate around. So the sprocket rotated on the cam. So the cam stayed still and the sprocket rotated, and then when it did start to move, it smashed all fucking valves up. Because there is no roll pin on the end of on the actual drive shaft. Sorry, on the cam shaft. On a K16 engine you've got the cam, but you don't have a locking mechanism on this side on K16 engine. But on this side you've got pins on your sprocket to show you, line grooves on your sprocket to show you where it goes. But it's got a roll pin in the end of the, very boring, but a roll pin saves all that happening. But it tends to chew all your belt up, you see. But sometimes it doesn't chew your belt up. But it's usually the head gasket that goes on a K16 engine, because it's a bad design. So I'm hoping that this one is not a bad design. But so far, that's a bad design. In fact, just because water pump went wrong and it got a bit warm, it smashed all fucking valves up. That's like a bad design, that. You know what I mean? I'm hoping it's not going to continue to do that. So if he does it again, I'll be really annoyed. But we'll find out.